All right, so let us start our session 2, which is about the selection of type of foundation. That how will you decide to which type of foundation is good enough to resist the coming demand from the structure, right? So these are the different factors which will affect the type of foundation. So this is the allowable bearing pressure of the soil, building type, whether it is residential or commercial, and the number of stories, if it is 5 stories, 10 stories, 20 stories, and the bearing area, the plot area, available area, which we have to, for the building, available plot area for the building for which we have to design the foundation, and the punching demand, water table level, and the type of surface, right? So these are the different factors which will affect the type of foundation. So the first one is the allowable bearing pressure of the soil, and this factor is mostly governed because our allowable bearing pressure is variable from place to place, and we have done a case study for the better understanding of how this factor will affect the selection type of foundation, and then the sizes of the structure. Ji Sanaola. Sanaola, do you have any question? All right. So this is a case study, and in which we have selected the allowable bearing capacity of the soil is 2 TSF. 2 TSF means 2 ton per square foot, which is equal to 4.408 kip per square foot, right? And the total surface load of the structure, because you have to compare or calculate the size of the footing using the service load, not the factor load. This is because the factor of safety is already be taken in the soil by dividing the ultimate bearing capacity by some factor 2 or 3, or normally is taken as a 3 to calculate the allowable bearing capacity. So for this purpose, we take the service load to calculate the area of the footing, right? So excuse me, please give me a second. So this is the total service load of structure, which is equal to 900 kip, and the type of footing is selected is isolated, which is 4 × 4 feet, and the total number of columns is 15, right? So the total bearing area is equal to the 15 into 4 × 4, that is equal to 240. So this is the 240. Let me write the units, that is the square foot, right? So this is the square foot area. This 240 square foot area is the bearing area, which will bear the load coming from the superstructure, which is equal to 900 kip, right? So if you divide this 900 by this bearing area, so it will be equal to 3.75 KSF, kip per square foot. This is the demand. This is the demand coming from the superstructure, and the available bearing pressure capacity of the soil is 4.408, which is less than the allowable bearing capacity. So the design is okay, right? So in the main concern in this case study, if the allowable bearing capacity is less and the demand is same, so what will happen? So if the allowable bearing capacity is equal to 0.75 TSF, which is equal to 1.65 KSF, right? And the load is same. If you divide 900, right, again, and if you compare this load, which is the same coming from the superstructure is 3.75, and it is greater than 1.65 the allowable bearing capacity of the soil, which is not safe, right? So then you have to shift to another type of footing, whether it is strap footing, combined footing, or mat footing, depending upon the case or the required demand. So after selecting the new footing, again you have to compare the demand and capacity, and so on. Then you have to move on, right? So this is how the allowable bearing capacity will affect the selection of type of foundation. This is the first factor. The second factor is the building type. The type of building superstructure also affect the type of foundation, but this is very rarely happens. For the residential building, if it is the load bearing wall system, so you obviously you have to go towards the wall footing or step footing. But if it is the confined load bearing walls, if it contains the columns inside the between the junction or the joint of the walls, then you have to use the combination of the footing, which is the strap footing or wall footing. It is not the you can say the strap footing or wall footing, plus you can also use the isolated footing as well, right? So if it is there is a veranda or there is a car porch and there is no support of the wall, so you have to go for the column, and then you have to use this combination of type of footing for your building, right? And for the high-rise building, raft footing is normally used when the water table is very low and having good bearing capacity of the soil, right? And the piles are very rarely used, but in some cases, if there is a high water level and the soil is very loose, then you have to go towards the pile foundation, right? So this is the building time factor which will affect for the selection of the type of the footing. The next factor is very important, that is the number of stories, that how you will decide or will affect the selection of type of the footing for your proposed building, right? So I have written that the number of stories have great impact on the type of foundation to be used. So again, there is a case study I have included in this lecture, that the case study says that the allowable bearing capacity of the soil is 2.75 TSF, which is equal to 6.06 KSF kilo pound per square foot. And the number of story of the proposed building is 14, right? So the total, this will normally will come if you design your actual structure for a 14-story building, and if it is the normal grade 20 cross 20 or 20 cross 25. So the total service load will come from the superstructure, that will be equal to 30,000 kips. And the type of footing you have selected is raft. And the total footing area, available footing area, is 500 square feet, right? For example, this is your plot, right? And if it is, for example, this is 70 feet width, and the other direction it is, for example, it is 100 feet, right? So the total available area for the raft will be equal to 7 into 100. So this will be the total available area for the raft footing. So this is what it means. I have written the total footing area is this available, or the bearing area, which we can use to design your raft, right? So, and the punching pressure we have to calculate next, that what is the demand coming from the structure in terms of the pressure. So the pressure of the building is the 30,000 divided by the footing area. So it comes out to be 6 KSF, and the capacity of the soil to resist the load is 6.06. It is almost equal, but it is slightly greater. So the design is okay. So you are on the safe side, right? But somebody want to say something? Okay, so the next is the number of story. For example, it is the same footing area available for the building And if the client want to increase the number of story, if it is want to build 17-story building, and the service load is now 38,000 kips because of the extension of the 3 stories, but the allowable footing area is the same. If you calculate the pressure coming from the superstructure, so that will be equal to 38,000 divided by the 5,000. So it will come out to be 7.5 KSF. So this is the pressure coming from the building demand, and this is the capacity. So the demand is greater than the capacity, so it is not safe. So what is the next step? You have to go for piles foundation, right? And how you calculate the how much load will be taken by the pile or the raft, it depends upon you, right? So if you want to consume the overall capacity of the raft and the remaining resisted by the piles, so then you have to subtract the allowable bearing capacity of the soil from the demand. So this is the demand and this is the capacity of the raft. So it will come out to be 1.44 KSF. So this much load will be resisted by the piles, or you can also give an option to the client so to decrease the number of story. I have written that the decrease the number of story. It means that if you suggest to the client that you cannot build the 17 stories on this raft, you must go for the piles. And if he say that no, I'm not interested in the pile, so then the next option is that you have to ask them to decrease the number of stories, so it can be easily resisted using the raft foundation, right? So this is how you will compare the bearing capacity with the demand coming from the superstructure. Is my voice clear?
Yes, it is.
Yes.
All right. All right, so this was the effect of the number of stories, that how you will change the type of foundation with the increase of number of stories. So the next factor is the bearing area of the plot area. Sometimes you are restricted to use the available plot area to design your foundation, or sometimes you will have a free hand to choose your own footing area. So again, we have this case study. This is the previous case study for the 17-story building. If the allowable bearing capacity is 2.75, which is equal to 6.06 KSF, and the total load is the same, it is 38,000 in all of these, and the pressure is the same, which is calculated. So it is 7.5 and the capacity is 6.05. So it was not safe in previous case, and we moved towards the piles, right? So now if the available area for the raft is more, what you have assumed in your calculation, you have assumed 70,000, 5,000, and you can increase the area for the raft. So then you do not have to go for the piles. What does it mean, right? For example, if this is the plot, right, and its dimensions are, for example, 100 feet, and these are the, for example, 200 feet, and you have done your calculation for the raft using this much area, right? And for example, this is the 50 feet, and the other one is, for example, this is 100 feet, right? And you have done your calculation on the basis of this, but this much area, the outer portion area is also the plot of the client, and you can consume these areas in your raft. So in this way, you have to increase the area, so you don't have to go towards the piles. So I have written that if you can increase the area to 7,000, then you can work with the raft. So you have to calculate the pressure by dividing this demand is the same, you have increased this area. So the demand is now, pressure is 5.4 ksf, which is less than the allowable bearing capacity of the soil, right? So this is how you can play with the areas and the number of stories to finalize your footing, whether it is up or down.
Excuse me, sir.
Gigi?
Sir, you have said that if we have the load more than the design load, then we need to reduce the number of story. So in case, sir, if we it will cause failure of the
Sorry for the
footing.
disturbance, but if you please write down all of your questions, and if you ask them at the end of this session, that so we can move on with your lecture.
Okay,
You
okay,
can
sir.
ask any type of question. You can ask number of questions at the end of the section.
Okay, sir.
Right.
Okay. We'll ask you. Okay.
So this is how the bearing area will affect the type of foundation. If you can increase the bearing area, so you can come from the piles towards the raft again, right? So the next factor is the very critical, which is the punching demand. In isolated footing or the raft footing, normally the punching is the main issue, but I have written in only for the isolated footing. When you have the punching issue, then you have to change your footing type to from isolated footing to strap footing by providing the strap beam, right? And in case of the raft, if you are restricted to use the, for example, 30 inches raft, you cannot increase the thickness of the raft, but there is no need to provide a strap beam in raft. You have to design integral beam, which we will be doing in the design of the raft. We will design integral beam for the raft as well in this course, right? So if the punching demand to capacity ratio for the punching share is greater than equal to 1, it is considered as a fail, right? So you have to increase the perimeter of the footing, or you have to increase the thickness of the footing, right? So the first solution is that you have to provide the strap beam to overcome this demand in case of the isolated footing, right? And the other solution includes to increase the perimeter area of the punching to solve this problem if you have enough plot area of the client, right? And again, if there is no solution, again you have to go for the step footing and the combined footing to overcome this punching demand, right? So this is very crucial, and you will face so many times during your design of your building if you are working in consultancy or you are working independently, right? So this is very crucial as well. This is the water table level. When the water table level is very high, then there is no doubt you have to go towards the pile foundation design, right? So you can see in this photo that, let me enlarge this. So you can see that there is a very high water table in this region, right? Whether it is soft soil or either it is rock, but if there is water table, high water table, there's water at the foundation level, then you have to go towards the pile foundation, right? So I have written, there is a question that what will happen when you provide shallow foundation, for example, raft foundation, isolated foundation, or strap footing or combined footing to the building. So what will happen, right? So this is very obvious that the bearing capacity of the soil will decrease with the moisture or with the water, and there will be settlement of the footing, whether it will be partial settlement, differential settlement, or it will be complete settlement of the structure, and the superstructure will collapse, right? So this is very crucial whenever you are designing your structure. When there is a high water table, so you have to go for the pile foundation design. And the question is that you will how you will know the water table level. You will get to know from the geotechnical report. You will see in detail that where is the water table level, right? Then you have to decide your type of foundation. Maybe you have to go for the raft, or you have to work with the piles foundation, right? So another factor is the type of surface. For example, there are two types of surfaces, which is plain. Normally in Peshawar, it's a plain surface. And if you are talking about the Murray, Aptabad, or Swat, it is a slopy surfaces, hilly areas. So in plane surfaces, different foundation type can be selected depend upon the different factors or the as per the demand. You can use the raft footing, piles footing, or isolated footing as per your requirement. Right? In case of the slopy surfaces, raft foundation can be used on these type of surfaces if the following conditions are satisfied. Right? The first one is the good bearing capacity. The soil type like SA, SB, SC, and SD. What are these? You can search it in the Building Code of Pakistan, or you can search it in UBC 97. So what are these definitions? And stable slope. This is most important factor in case of the slopy surface in hilly areas. If the surface is not stable, there is no stable slope, then you must go for the piles. If any of these condition is not satisfied, you must go for the piles foundation. Normally, these two are satisfied in most of the cases, but this is not satisfied in most cases. So people design this buildings in these slopy surfaces on this condition, and they design piles foundation. Right? So this was the whole story about the selection of type of foundation, and we have studied different case studies. So if you have any questions, you can ask any type of question.
Sir, I have a question. If the water table is, for example, within 1 or 2 meter below the footing, so what will you do in that situation? Or secondly, what is the acceptable range? You told that you go for piles when the water table is too high, but what to if we have this without piles the footing, the you say the mat footing or the isolated footing.
You can ask
So how will
question
we-
in Urdu and Pashto for the better understanding.
Okay, okay. I think I am explaining it properly. वहाँ पे जहाँ पे आपका वाटर टेबल बहुत करीब हो आपके फुटिंग के
जी मैं
डेप्थ
समझ
से
गया,
के
लेट
साथ,
मी आंसर दैट।
तो
आप
वहाँ पे
रेंज
आप क्या
पूछ रहे,
करेंगे?
आप रेंज पूछ रहे कि कौन से रेंज तक
जी जी
हम
जी
राफ दे सकते हैं, या उस रेंज से बढ़कर हम पे राफ दे सकते हैं। नॉर्मली डिजाइन में अगर आपके पास 20 फीट से ऊपर, फॉर एग्जांपल लेट मी शो इट हियर, नॉर्मल प्रैक्टिस आपके पास, फॉर एग्जांपल ये आपके पास राफ्ट लेवल है, ठीक है जी, और आपके पास वाटर टेबल बिलो एट 20 फीट, राइट? अगर आपके पास ये 20 फीट तक है, सो नाउ यू कैन डिजाइन इट एज अ राफ्ट। लेकिन अगर आपके पास ये 20 फीट से ऊपर आ जाए तो देन यू हैव टू गो फॉर द पाइल्स, राइट? But it is not the actual thing. This is the thumb rule. All you have to do is to calculate the pressure bulb, right? I think you have studied in your tech courses that you have to calculate
Yes,
the
the
pressure
Boson's
bulb.
equation.
And if the water table is not in the range of the pressure bulb, then you are in the safe. For example, the water table is at this level, so you are in the safe side. But if the water table is inside the pressure bulb, so then you have to go for the piles, right? So there are some equations or formulas which can be used to calculate the pressure bulb, and you can use those formulas to calculate the pressure bulb. What is the depth of what is the depth for the pressure bulb for my structure, right? So if the water table is not inside the water table is not inside the pressure bulb, then you are on the safe side, right? So the normal thumb rule is 20 feet. If the water table is below the 20 feet, then you can design the raft. If it is 20 feet or less than 20 feet, then you have to go for the piles. But again, this I just told you that
Too much noise.
this
Yes, sir.
20 feet is only for the residential dwellings, like two-story or
نه نه داسې خو مې نه
three-story.
دي سره شیټس مې تاسو ته جوړ کړ چې تاسو یې نظر وګورئ بیا به زه دې ته راوړم سر
Sir,
بس
too much
هغه
noise.
زیات تر خو ما ځینې کې هغې کې ریفیوزل کنسیډر کړی مې ته ویستو نو ریزلټس کې چینجز راغلل.
Sir, kindly explain. There was too much noise.
So I was talking about the pressure bulb, that if you calculate the pressure bulb for your structure, for example, if you have 2 or 3 story buildings, that this 20 feet thumb rule is enough. So for example, if you have 3-story commercial building and the water table is below 20 feet, then you are on the safe side. But if the water table is above the less than or the 20 feet, then you have to go for the piles, right? So there are some formulas and equation which can be used to calculate the pressure bulb. And if the water table is below the pressure bulb, then you are on the safe side. But if the water table is inside the pressure bulb, then you have to design it for the piles as well.
Okay, got it, sir.
Right?
Excuse me, sir.
Sir,
जी
सर 2 कॉलम के दरमियान में कितना डिस्टेंस होना चाहिए कि हम कंबाइंड फुटिंग दें या स्ट्रैप फुटिंग दें?
देखिए, इसमें ऐसा कोई रिक्वायरमेंट तो नहीं है, ये तो आप एज पर यू रिक्वायरमेंट और आर्किटेक्ट, आप फॉर एग्जांपल अगर आपके पास आर्किटेक्ट ने एक प्लेन बनाया है, फॉर एग्जांपल दिस इज अ प्लेन, और उसने 2 कॉलम्स इस बहुत करीब दिए फॉर द आर्किटेक्चर पर्पस और फॉर द अदर रीजन, then you have no choice to combine this footing and design it as a combined footing, right? So if the, for example, if this is one column and this is the other column, right? And if you want to design it as a isolated footing and the area for the isolated footings come out to be very large, then there is no restriction that this much thickness, this much spacing should be in between the columns to make it as a combined footing. So you have to go for the combined footing automatically. Normally what happens is that we design it as a strip. For example, this is the column layout. For example, this is the column, this is the column. If you design this as a combined footing, so for example, this is the combined footing for these two, and this is for these two, and this is for these two, and this, so it becomes the strap footing. So this is how the designer do the combined footing design. So all of the column is included in the combined footing, so it becomes like a strip like this, right? So there is no thumb rule or restriction on the spacing of the column. You can combine any column with any distances. जी,
Sir,
आपको ये क्लियर है?
Yes, sir, clear. Thanks.
जी, अगर किसी का कोई क्वेश्चन है तो काइंडली पूछ ली।
सर जी, ये
Sir,
कंबाइन या जी पूछ लें।
सर हम confined load bearing और simple load bearing में क्या डिफरेंस है?
अच्छा जी, let me erase this. एक्चुअली आपके पास जो कंबाइंड फुटिंग, आपके पास जो कन्फाइंड ब्रिक मिशनरी होती है और अनकन्फाइंड ब्रिक मिशनरी होती है। फॉर एग्जांपल, ये आपके पास एक वॉल है, आई एम जस्ट शोइंग इट्स एलिवेशन, राइट? तो इसमें सिर्फ आपके पास ब्रिक्स होंगी, आपको ब्रिक्स नजर आएंगी, राइट? राइट, तो जब आपके पास कोई बिल्डिंग हो, उसमें सिर्फ आपके पास ब्रिक्स हो, कोई उसमें कॉलम वगैरह ना हो, तो दिस इज कॉल्ड द अनकन्फाइंड ब्रिक मिशनरी। लेकिन अगर आपके पास यही वॉल है और इसके मिड में मैं एक कॉलम प्रोवाइड कर लूँ, विच इज नॉर्मली द इक्वल टू द थिकनेस ऑफ द वॉल। फॉर एग्जांपल, दिस इज द कॉलम and this column is normally equal to 9 inches cross 9 inches. So these are the walls, right? So this is the brick, you can see these are the bricks and this is the column. So when you provide column in between the junction of the two masonry walls, it becomes the confined brick masonry. And there is a beam, there will be a beam running on the lintel level, and it will be confining the columns all around the structure. So this structure is called as the confined brick masonry, and this is the unconfined brick masonry, right? So when there is a column in between the junction of the wall, it is confined. When there is no column in between the junction of the brick walls or the block walls, it is called as unconfined brick masonry, right? So this is the
sir,
difference.
okay.
जी हाकिम,
सर ये कंबाइंड फुटिंग या मेट या राफ्ट फुटिंग जो है इसकी डेप्थ वेरी कर सकता है एक सिंगल फुटिंग की?
समझने क्या कह रहे हैं आप? फॉर एग्जाम्पल आप ये कह रहे हैं कि मेरे
मसलन
पास एक आइसोलेटेड फुटिंग है, दूसरा कंबाइन है, तो दूसरों एक दूसरे की थिकनेस कम ज्यादा हो सकती है, ये पूछ रहे हैं?
नहीं मैं कह रहा हूँ मेरे पास एक सिंगल कंबाइंड फुटिंग है
जी
या एक राफ्ट फुटिंग है मेरे पास, उसमें फर्ज कर लो 3 ग्रिड है कॉलम्स की, जो सेंटर वाली ग्रिड है उसमें मैं डेप्थ वेरी कर सकता हूँ क्या? उसकी डेप्थ बढ़ा सकता हूँ?
जी जी बिल्कुल, आप बढ़ा सकते हैं उसको कॉलम पिट कहते हैं। फॉर एग्जाम्पल ये आपके पास राफ्ट है, राइट? ये ओवरऑल इसकी
जी।
थिकनेस फॉर एग्जाम्पल 30 इंचेस आपने प्रोवाइड की है, लेकिन आपके पास
जी।
मिड में सिर्फ एक कॉलम है जिसके लिए आपको रिक्वायर्ड है कि उसको 36 इंचेस थिकनेस चाहिए टू ओवरकम द डिमांड ऑफ पंचिंग। तो आप यहाँ पे एक कॉलम
जी।
पिट प्रोवाइड करेंगे, एक यहाँ पे आप पिट शो करेंगे ड्राइंग में, और आपको उसको क्रॉस सेक्शन में इस तरह शो करेंगे। फॉर एग्जाम्पल ये आपके पास राफ्ट जा रही है, तो ये आपके पास एक यहाँ पे पिट आ जाएगी कॉलम के नीचे, और ये ओवरऑल इस तरह राफ्ट आपके पास जाएगी। तो ये आपके पास ये थिकनेस आपके पास 36 आ जाएगी और ये आपके पास 30 आ जाएगी।
ओके सर। अच्छा सर, हमारे पास कोई थंब रूल है बेरिंग कैपेसिटी उस हालत में जब हमारे पास कोई जो टेक इन्फॉर्मेशन ना हो? मोस्टली जैसे हम आम बिल्डिंग करते हैं ना डिजाइन, तो उसमें हमारे पास कोई खास जो टेक इन्फॉर्मेशन उसकी नहीं होती है, तो हम बेरिंग कैपेसिटी पर कितने लेते हैं, अज्यूम क्या करते हैं, या कोई
जी बिल्कुल
रेंज?
एज्यूम करते हैं। आपके पास नॉर्मली रेजोल्यूशन बिल्डिंग के तो टेस्ट नहीं किए जाते, लेकिन आप इलाकों के
हाँ।
देखेंगे। फॉर एग्जांपल अगर आप पेशावर की बात करें तो यहाँ पे हम 1 TSF एज्यूम करते हैं क्योंकि यहाँ पे सॉइल अच्छा है, राइट? लेकिन अगर आप दूसरे बनू साइड पे जाए या अपनाबाद पे जाए तो आप बेरिंग कैपेसिटी काफी अच्छा है, तो आप उसमें आप 1.5 या 2 भी एज्यूम कर सकते हैं, लेकिन नॉर्मली डिजाइनर के पास 1 पे एज्यूम होता है। ये आई एम टॉकिंग अबाउट द रेजिडेंशियल बिल्डिंग्स। कमर्शियल बिल्डिंग्स और हाई राइज बिल्डिंग के लिए आप कभी भी सॉइल रिपोर्ट के बगैर डिजाइन ना किया करें,
ओके सर।
ठीक है?
अच्छा सर, दूसरी बात ये जो टोटल सर्विस लोड ऑफ स्ट्रक्चर है वो हम तमाम कॉलम के जो लोड आएगा उसको प्लस करेंगे, या हमें सॉफ्टवेयर में कहीं से ये मिल सकता है?
जी जी बिल्कुल, ये सॉफ्टवेयर में अवेलेबल है। मैं आपको शो करूंगा कि सॉफ्टवेयर में आप कहाँ से ये उठाएंगे,
ओके सर, थैंक यू।
ठीक
ठीक
है?
है।
आप सारे जो कॉलम है उसको लोड जमा भी कर सकते हैं और विथ 1 क्लिक आप फाइंड भी कर सकते हैं। लेकिन अगर आपके पास 300-400 कॉलम्स हो, उसको सारे रिएक्शन को ऐड करना ये बहुत लेबोरियस जॉब है। इसके लिए आपके पास एक ऑप्शन है, वो मैं आपको बताऊंगा। आपको डायरेक्ट सर्विस लोड आपको बताएगा कि इतना है, तो आप उस सर्विस लोड को एरिया पे डिवाइड करेंगे, आपको पता चले कि प्रेशर कितना आ रहा है,
ओके सर, थैंक यू सर।
ठीक है जी?
सर ये जो हम ये लोड जो बिल्डिंग का जो फेलियर क्राइटेरिया डिस्कस करते हैं, तो इसमें इधर जो विद रिस्पेक्ट टू स्ट्रक्चर हम सिर्फ ये पंचिंग डिस्कस कर लेंगे, या अदर देन पंचिंग भी कुछ क्राइटेरिया आप डिस्कस करेंगे? उस अगर कोई हो तो सर उस पर कोई थोड़ा बात करें।
समझ नहीं आई, काइंडली रिपीट करें क्वेश्चन।
अच्छा सर, मैं ये कह रहा हूँ कि अगर हमारे पास लाइक स्ट्रक्चर अभी फेल हो रहा है ना, तो उसमें हम कौन से क्राइटेरिया डिस्कस करेंगे फेलियर का? पंचिंग या अदर देन पंचिंग भी कुछ उसमें होगा?
स्ट्रक्चर आप फाउंडेशन फेलियर की बात करें कि फाउंडेशन फेल हो रहा है,
ये
तो
बिल्कुल बिल्कुल एग्जैक्टली यस सर। अभी
आपके पास
फाउंडेशन अगर
नॉर्मली
हम
जो फाउंडेशन की 2 फेलियर्स होती है आपके पास, या ये बेरिंग में फेल होगा या आपके पास शेयर में होगा। शेयर मींस कि पंचिंग में फेल होगा। ये 2 फेलियर्स होंगी जो हमने यहाँ इस लेक्चर में डिस्कस कर ली। एक फेलियर आपके पास अपलिफ्टिंग है। अपलिफ्टिंग मींस कि आपके पास एक फॉर एग्जांपल लेट मी शो इट हियर, आपके पास ये एक फुटिंग है, आपने सॉफ्टवेयर में चेक कर लिया कि ये कॉर्नर आपके पास जो डिस्प्लेसमेंट है ये आपके पास पॉजिटिव आ रही है, ये आपके पास नेगेटिव आ रही है। तो नेगेटिव आ रही है, इसका मतलब ये कि ये डाउनवर्ड जा चुका है, विच इज गुड, ये कंप्रेशन में है, लेकिन पॉजिटिव का मतलब ये है कि ये अपवर्ड जा चुका है, इट मींस ये अपलिफ्ट हो चुका है. टू ओवरकम दिस प्रॉब्लम यू हैव टू इंक्रीज द एरिया और यू हैव टू प्रोवाइड द स्ट्रैप बीम, राइट. ये 3 किस्म के फेलियर्स आपके पास होते हैं, लेकिन अपलिफ्टिंग आपके पास बहुत रेयरली होते हैं. नॉर्मली आपके पास बेयरिंग में फेल होते हैं या शेयर पंचिंग में आपके पास फुटिंग फेल होती है.
बेयरिंग मीन सर सेटलमेंट.
जी जी बिल्कुल,
के
सेटलमेंट
मतलब
आपके पास होगी,
ओके
सवाल आपके पास सेटल होगी. ठीक है जी.
ओके थैंक यू.
जी, if there is any question you can ask. All right, so if there is no question, so this is the end of session 2, and we will meet inshallah tomorrow with the design of the isolated footing.
एक्सक्यूज मी सर, ये लेक्चर तो रिकॉर्ड हुई है ना, ये जो लेक्चर अभी थी?
जी जी बिल्कुल, ये रिकॉर्ड हुए. मैं आपके साथ अभी 2-3 घंटे बाद इसकी लिंक शेयर कर दूंगा, आप फिर उसको देख सकते हैं.
ओके सर, शुक्रिया.
Sir, can we change some time? I mean, इस टाइम पे मैं ऑफिस में होता हूँ, तो can we change the time to 7 o'clock?
जी जी बिल्कुल, ये तो 7 o'clock मैंने किए थे, कुछ स्टूडेंट्स ने रिक्वेस्ट की थी, लेकिन कल अनफॉर्चुनेटली यहाँ पे लाइट चली गई थी 7 बजे, तो हमारे पास फिक्र ये थी कि दोबारा 7 बजे ना चले जाए, तो इसलिए हमने ये 6:15 पे स्टार्ट की. तो चले इंशाल्लाह कल देखते हैं, अगर ये टाइमिंग सेट हुआ तो 7 बजे स्टार्ट कर लेंगे.
Sure, please.
लेकिन
Thank you.
नॉर्मली स्टूडेंट्स कह रहे हैं कि हम 6 बजे फारिग होते हैं, तो 7 बजे लेट होता है, तो इस वजह से हमने 6:15 कर दिया.
Sure.
चलिए आप ये ग्रुप
ज्यादातर
में,
लोग
व्हाट्सएप ग्रुप में आप वोटिंग कर लेना, जितनी स्टूडेंट्स की वोटिंग ज्यादा होगी तो वो टाइम हम डिसाइड
ठीक है
करेंगे.
ठीक है सर. Thank you.
चलिए, so this is the end of this session. See you tomorrow inshallah.